an engineer is designing the runway for an airport. Of the planes that will be used at the airport, the lowest acceleration rate is likely to be 3 meters per second squared. The takeoff speed for this plane will be 65 meters a second. Assuming this minimum acceleration, what is the minimum allowed length for the runway? So, of our variables, we have an acceleration, we have a final velocity, and we're looking for a distance, or a delta x. These are the formulas that we'll be using. And of these formulas, the most useful one is going to be right here. x2 equals x1 minus initial velocity times acceleration times time plus 1/2 a times delta t2. Now, if we start plugging in our numbers to our formula, we see that basically the first half of the equation is pretty much pointless. So what we can do is, what we're looking for, the x2, just use the second half of the equation. What we have for the second half of the equation is the 3 meters a second, but we do not have a time. But thanks to the fact that we have a velocity and we have an acceleration, we can use the formula for acceleration to find delta t. How we do that is we derive that acceleration is equal to the change in velocity over the change in time. Well, we're looking for the change in time. Through that, we derive that the change in time is equal to the change in velocity divided by the acceleration. So from there, delta t equals 65 meters a second divided by 3 meters a second squared. That gives us 21.67 seconds before that plane is able to take off. Now, thanks to the rest of our equation, x2 equals 1/2 times 3 meters per second times 21.67 seconds squared means that our runway has to be 704.17 meters long.